Okay, we are live. If there is anybody in the chat section, please let me know. Am I audible? Just let me know. Am I audible and visible to all of you? Just give me a thumbs up in the chat section so that I'll know everything is fine with my stream. Okay, everything is fine. Let's just wait for 1 minute so that students can gather and we'll start our today's stream. So in our today's stream, we are going to discuss LU decomposition in detail, that how to find LU decomposition, and we'll discuss some questions which are previous year question and some important question which we'll think that important for GATE point of view in 2023. We'll discuss those questions. So just share it with your friends so that they can also get this session. Okay, so anybody know what is LU decomposition? Any idea about that, about LU decomposition? Anyone have any idea about LU decomposition? Okay, so let's suppose if A be any matrix, right? A be any n cross n matrix, that means square matrix. Then the LU decomposition of a matrix is the breakdown of this A matrix into L, which is lower triangular matrix. All of you know what is lower triangular, right? L11, L22, like this, LNN, and this whole term will be 0, L21, LN1, right? And for upper triangular is U11, U22, like this, UNN, and this lower part will be 0, right? U1N, like this. We have a matrix which is upper, which have numbers in upper triangle, right? And lower triangular is which has numbers in lower triangle. So I can write A as L into U, right? So that is a LU decomposition. We have breakdown our matrix A into lower triangular matrix and upper triangular matrix. That means L into U, right? Okay, so that is LU decomposition. So basically what we have to do, we just have to find a breakdown for the matrix A such that we can write A as a product of lower triangular matrix and upper triangular matrix. When we try to solve questions using LU decomposition, the system of linear equation, it will get easy. But you do not have to solve question by LU decomposition. You just have to know for gate point of view that how to find LU decomposition, that is enough. So how would you do? One thing is, let's see, first method is, let's suppose if I have uh, let's suppose if I have a 2 cross 2 matrix, 1 2 3 4, like this, right? I'll write L11, L12, L22, and this is L21, and this is 0, this is L, and I'll take U as 1 1 0 and U2 1, right? U12, this is a upper triangular matrix, this is a lower triangular matrix. What I'll do, I'll take the product. Let's find out LU. What we'll get? L11, L11, U21, L21, L21, and the last term will be L21, U21, U12, U12. This is U12 and plus L22. Now, on comparing it with A, I can simply find out all the terms L11, U12, L21, U22, right? I can find out all the terms and then I can write LU decomposition of a matrix, right? That is easy, but it is easy only for 2 cross 2 matrix, because if I'll have 3 cross 3 matrix, then it would be difficult for me to find out the same thing for this, because then I have 6 variables in L matrix and 3 variables in U matrix, right? That means in total I have 9 variables, and then I have to solve for 9 variables. That will be very lengthy. So we'll discuss one method which in detail in the later slides, that how to find LU decomposition if we have a 3 cross 3 matrix. Right? For 2 cross 2 matrix, I can do that because we need only 4 variables. But it's up to you, either you want to do this by or by another method. We will discuss this another method in the later slides. First, let's solve some question based on this method, right? Okay, so let's do that. So we have one question from GATE CS 2015. It says that in the LU decomposition of the matrix, we have given a matrix A. Let's write it as A, 2, 2, 4, 9. If the diagonal elements of U are both 1, right? Diagonal elements of U are both 1, right? That means we have this distinct element U12. Then the lower diagonal entry L22 of L is. If U is 1, 1, then L will become L11, L12, sorry, this will be 0, L12 and L22, right? This will be our lower triangular matrix. This will be our lower triangular matrix, right? Now I can find out LU. What will become LU? LU will become L11, right? L11, L11, U12, and this will become L12, and this will become L22, right? This is a matrix. Now I can compare LU with A, right? I can do that. Let's compare A with LU, right? Just tell me what will be the value of L11 when I compare A with LU, right? What would I get? Okay, let's see. Here we have equals to A. A is equals to 2, 2, 4, 9. Let's see. We get L11 equals to 2 here. We get L11 equals to 2. Okay, on comparison, now L11 is equals to 2, and then we get L11, L11 and U12 equals to 2. But L11 is equals to 2. If I'll put the value of L11, what would we get? We will get U12 is equals to 1. Right? Now, the next term will be L12. Now, on comparison, I can check that L12 is equals to 4 and L22, if both if the diagonal elements of U are both 1, right? And we have to find out lower diagonal entry L22 of L, right? Okay. Okay, so we have multiply. Okay, L22. Okay, this will become L12 U12 plus L22, right? L12, because we have multiplied L with U. By mistake, I have done with U with L. L this row and this column. This will give me L12 U12 plus L22. Let's write down L12, L12 and U12 plus L22 equals to 9. We have L12. L12 is equals to 4. L12 is equals to 4 and U12 we get 1, right? Plus L22. What we will get from here? L22 is equals to 5. Which option matches to our answer? Option B matches to our answer. So basically we have to just simplify. We have to take L and U. There is one thing you just have to remember. Either you can take all the diagonal entries of U as 1 or L as 1, because they have given that diagonal entries elements of U are both 1, right? We have taken diagonal elements of U are both 1, so I cannot take L as 1, right? So either I'll take for U, either I'll take for L. Here I have taken for U, right? Okay, so that's why we have taken L12, L22 as lower triangular matrix. Okay, I hope this is clear. If there is any confusion in this question, just let me know. Because this is the basic question based on LU decomposition. Later on, we'll discuss some 3 cross 3 matrix, and we do not solve the 3 cross 3 matrix by this method because this will get very lengthy. We'll discuss another method in detail in the lecture. Just let me know if there is any confusion. Okay. So I hope there is no confusion in this question. So basically you have to take one L matrix and U matrix. L is lower triangular, U is upper triangular. If they have given that you have to take U and diagonal entries of U as one, then you will take diagonal entries of U as one. Otherwise you can take off any diagonal entries one of any of the matrix from L and U, right? Okay, so let's move forward. Okay, so this is another question. It says that in the LU decomposition of the matrix, if the diagonal elements of U are both 1, then trace of L is. So we have to find out the trace of L. Okay, so we have discussed one method in which we can find out the LU decomposition. So let's do that. So let's take L as L11, 0, L22 and L21, right? This is L matrix. Let's take as U as U11. Okay, we have to take diagonal entries as 1, 1, and let's take it as U12, U12 and this one will be 0, right? So LU will be L11, right? And this will be L11, U12 and this will be L21, right? And this will become L21, U12 plus L22, right? Again I'll compare. On comparison, let's do compare with 1, 2, 3 and 8. On comparison I'll get L11 is equals to 1. Now again on comparison L11 U12 is equals to 2. Let's put L11 is equals to 1, so we'll get U12 is equals to 2, and on comparison we'll get L21 is equals to 3, right? Now let's solve for L22 because we want trace of L. So L21 U12 plus L22 is equals to 8. L21 is 3, U12 is 2, L22 is 8, right? Now from here I can get L22 is equals to 2. So I can check that L11 is equals to 1, L22 is equals to 2, trace is equals to sum of diagonal entries, right? What is trace here? Trace is sum of diagonal entries. So here we will get 1 plus 2, which is 3, right? Is it clear? It is basically similar to the previous one, right? What we have done in the previous question, it is exactly similar. But again, we have discussed that we are not going to use the formula, use this method to solve 3 cross 3 equation, right? Okay, guys, please let me know if there is any confusion in this method. Otherwise, we'll move forward to the next method. If it is clear to everybody, just give me a thumbs up in the chat section so that I'll know everything is fine with this method. Right? Just give me a thumbs up and we'll move forward to the next method. Okay, so let's see next method. Okay, so I can check that here we get trace 3. Let's see another method. So what we have to do, we just have to row reduce this matrix and make all the diagonal entries 1, right? We are going to use row reduced. So let's do that. Here I have to make this 3, 0 because here is itself 1, right? I do not have to use transformation here because it is already 1. So let's use this. So what would I do? R2, what would I do? R2 implication R2 minus 3R1, right? So what would I get? 1, 0, 2, 3, 2 just 6, 8 minus 6, that will be 2, right? Is it in, is it in uh, row reduced echelon form, right? So let's take, here we have used one transformation in this, we have used one transformation, we had made this 3, 0. So what would I do? So if I'll form lower triangular matrix, okay, okay, I cannot use uh, here this operation, right? Why I cannot use? Because diagonal elements of U are both 1, right? Upper triangular matrix is 1. So what I can do here is 1, 3, 2, 8. I'll form this 0, and this one 1, right? Then I'll get upper triangular matrix. So let's take L as this. Let's form this as, okay, let's see. Right, we have this matrix 1, 2, 3 and 8, right? Let's form this lower triangular matrix, right? Let's make this to 0. So what would you do? R1 tends to R1. First you have to make this 8 0, right? To make it lower triangular, either you will make this 2 0, right? Or first you will make this 8 1 and then you will use it to make 2 0. Let's do that. So I'll use the operation first. R1 tends to R1 minus 1 by 4 R2, right? What would I get? 1, oh sorry, 3 8, let's write it as it is, and you will get here. No, you can't do that. Okay, so you can't apply this operation when you have given diagonal elements of u are both 1. You can apply only when you have given, when you can convert, you can take L as diagonal entries of L as 1, right? But here we have given diagonal elements of u are both 1, so we cannot use here, right? Let's see next question. In this we can do that, right? Again, in this question we have to find out the LU decomposition of this matrix. So what would I do? I'll use the operation R2 tends to R2 minus 4R1, right? I'll make this 0. So what would I get? 2 1, 4 2 ja 8, 8 minus 8 0, and 7 minus 4, that will give me 3. So this is our upper triangular matrix, and here lower triangular matrix will be, let's take diagonal entries as 1, and because we have subtracted 4 from this, so let's take here 4, right? Now if you will multiply 1 4 0 1 with this 2 1 0 3, you will get the matrix. So what would I do? 1 into 2, 4 into 0, you will get 2. 1 into 1, 4 into 3, 1 4, just a minute. Okay, this is a lower triangular matrix, so 4 will be there and this here will be 0. Okay, there is some confusion because 4 will be, because it is a lower triangular matrix, so 4 will be here, and let's multiply now. This will be 0 and this will be 4. 1 0, this will be 4. Now 4 2 ja 8 and 4 1 ja 4, 5 6 7. So we'll get A as L into U matrix. So this is L and this is U. We'll get LU decomposition. So whenever we have to find out LU decomposition of a 3 cross 3 matrix, what would I do? I'll just reduce it into echelon form, and the operation which I am applying here, if I am subtracting row 2 from, if I subtracting 4 from row 2, I'll add here 4, right? That's how I'll get LU decomposition of the matrix, right? Let's see next question. This will get, this will help you to get more clear answer of LU decomposition, because that will be a 3 cross 3 matrix, right? We have this question. They ask us to find out the LU decomposition, right? But we know that it would be difficult for us to find out the LU decomposition using this method. I'll multiply L with U. That will be a great, that will be a lengthy process, right? So what would I do? I'll use LU decomposition. So what it will be? Let's write it down. So we have 1 1 minus 2, 1 1 minus 2, right? And the next row is 1 3 minus 1, 1 3 minus 1, and the next row is 2 1 minus 5, 2 1 minus 5, right? So let's row reduced this, right? Let's make this 0 and this 0. So and L here will be, let's take all the diagonal entries 1. First I'll make this 0. R2 tends to R2 minus R1. So that means I am subtracting 1 from R2. So let's use it here 1, right? Let's use it here 1. So what would I get? 1 1 minus 2, and we'll get 0. 3 minus 1, 2 minus 1 plus 2, 1, right? And this R3, R3 tends to R3 minus 2R1, right? I am subtracting 2 from R1. So that means here I'll use 1 by 2, right? Here I'll use 1 by 2 because I am subtracting 2 from here. So what would I get? I'll get 0 here and 1 minus of minus 2. So that means minus 1, right? Minus 1. Okay, I am subtracting 2, so here I'll add 2, right? If I'm subtracting here 2, so I'll add here 2, right? Let's write down here 2. Here we'll have 2. Now we'll have here R3 minus 2R1, R3 minus 2R1, so we'll get here minus 1, and here we'll have minus 5 plus 4, minus 5 plus 4, that will give me minus 1, right? Now again, I have to make this 0. What would I do? R3 times 2, R3 plus 1 by 2, R2, right? That will make it 0. Now I am adding 1 by 2, so that means here I'll subtract minus 1 by 2. What would I get? 1 1 minus 2, 0 2 1 0, minus 1 plus 1, that will be 0, minus 1 plus 1 by 2, that will give me 1 by 2, minus 1 by 2, right? Now on comparison with the L and U matrix given here, L33 is this, right? L33, L32, we want L32. L32 is minus 1 by 2, L32 is equals to minus 1 by 2, and U33 is equals to minus 1 by 2. Let's see which one of the option have this L3 minus 2 minus 1 by 2 and U33 minus 1 by 2. This option will have this, right? L32 minus 1 by 2, U33 minus 1 by 2, and none of the option that have this value. So there is no need to find the value of x1, right? There is no need to find this value of x1 because I can simply directly tick option A. So here option A is correct, right? Okay, so any confusion in this, just let me know if there is any confusion in this question. Okay, so that will be easy. So what you have to do, you have to row reduce this echelon form and check what you are getting, right? You have to row reduce this echelon form into echelon form, and the matrix you will get after reducing is upper triangular matrix, and you have to, at the same time, you have to put the values. If you are subtracting here, then you have to add 1. If you are subtracting 2 with respect to R1, you have to add 2, and you can also check multiplying with L with U, you will get the matrix as A, right? Okay, so that's all about LU decomposition, right? So I hope there will be no confusion between LU decomposition, right? How to find? There are two methods to find LU decomposition. First, for 2 cross 2 matrix, you can simply multiply L with U and you can simply answer the question. And the next method is that you will row reduce the echelon matrix into echelon form. The row reduced echelon form is upper triangular matrix, and correspondingly you can form the lower triangular matrix, right? Okay, I hope this is clear to everybody. Okay, so guys, if you are, I have a great news for you. If you are a GATE aspirant, and uh, I have a news for you that GFG is launching its scholarship test 3.2. Scholarship test 3.2, and it will going to be live on 27th of May, right? So you can register this for the scholarship test on the link given in description below, and I hope you will register on this link as soon as possible, because in this scholarship test you will get an exposure, right, to all the questions, right, which are there, and also at the same time you will get an opportunity to get admission in our best gate live batches, right? So that would be very helpful with the flying discount, like top 1 to 3 rankers will get 75% discount, and 4 to 10 will get 50% discount, and many more, like 11 to 50 will get 25% discount, and furthermore 10% discount will be there for further rankers. So guys, this will be a great opportunity for you, and you will get to enroll in our gate live batches, in which you can learn so much for gate. That would be very helpful, and we have our best faculty there, so you can score, you can also work on your doubts, and they can also help you to work on your doubts and all other things, so you can go there. So guys, there is a link given in description below for this test, right? So you can register yourself now, and later on you can give this 1 hour test on 27th May at any time. Okay. So guys, if anybody have any question regarding this scholarship test, they can ask me, or anything about LU decomposition. Otherwise, I'll wrap up this session. Any questions? Okay, I hope everything is fine with LU decomposition. In the next session, we are going to start discrete mathematics, which is the first topic is propositional logic. So we'll discuss all the basics of propositional logic, and then we'll move forward to work on the questions for for that. Okay, so guys, all the best for your preparation. And if you have learned from this session, just subscribe to our channel if you haven't already subscribed, and like the session.